It's just what happens this time of year. I forget stuff. Yeah. Yeah.
So cotangent of theta equals 0.
Excellent. Great question. Cotangent of theta is equal to 0. And I would switch it and I would say, where is tangent of theta equal to undefined? And so as you consider the unit circle, we look at these pieces. And here's two ways to think of it that can help you do this more quickly. And this coordinate here is 1, 0, right? And this is 0, 1, right? So if you divide these two, you get 0, whereas if you divide these two, you get undefined. So that tells me a tangent is 0 here and here. It's undefined here and here. So it's undefined at 90 and 270. Now, let me show you how I never look at the unit circle. I remember something else. I remember this cool thing. Tangent is y divided by x, right? Or in other words, tangent is the same thing as slope. Slope is 0. Slope is undefined.
Okay.
And that's how I remember tangent all the time. It makes it easy. Tangent equal to 1 when the slope is 1, 45 degrees. Negative 1. See what I'm saying? That's how I think of it every time. I think a tangent is slope. All right. So the only thing we have to make sure we do today, we called ZZ out during lunch and said that she has to laugh at my jokes today. So we'll see if that happens. If it doesn't, we'll have to start all the problems over. Okay? So everything I say is funny when I'm joking, and you need to figure it out. So, all right? Don't roll your eyes at me, okay? All right. Here we go. Ordered trigonometric equations. That's what we got to do today. Find solutions to satisfy theta between 0 and 360. You already know how to start some of these. What do you do the first problem? You're going to subtract 2. Look at that. So to the person who writes IDK on the test, I say, I'm angry at you because you do know how to start it. Now what do you do? Divide by 4. Sine of 2/3 theta is equal to negative 1/2. But now you're like, shoot, there's something different with this problem than the other problems. What is it? That thing in front of the theta. Goodness, how dare they? But it is something important. We need to learn to deal with it. The fact is this 2/3 is going to have to come off of that theta. What moves first, the sine or the 2/3? Sine moves first. And so to get sine off of that, we sine inverse. So we sine inverse. And so when we sine inverse, we create that quadrant. Where is sine negative again? Bottom 2, the 3rd, and the 4th. I inverse 1/2, and you've all memorized this. The sine inverse of 1/2 is 30. And so you come up with 2 angles. What are those 2 angles? 210 degrees and 330 degrees. Now on the left-hand side, remember you just inverse, so the sine is gone, and what remains is 2/3 theta. So you're going to multiply by 3/2. You get theta is equal to 210 times 3 is 630, divided by 2 is 315 degrees. And 330 times 3 is 990, and 990 divided by 2 is 495 degrees. And those are 2 solutions. Now, please note that it says that theta should be between 0 and 360. I came out with a value outside of 360. Now, it's not that much work to just cross it off, but you don't have to. When I say in the directions, find theta between 0 and 360, I'm more concerned that these angles, and that's what I'll judge, is that your first 2 angles that you come up with are between 0 and 360. Got that? Yes. You can leave that. I want both of them. Both of them that result from these 2. You may say, well, it's no big deal, Mr. Gens. Well, in the second one, it is a bigger deal. This could end up being very challenging for you, and I'll show you why. Second example, I have now a 3 in front of the theta. What should we do? You are going to subtract the cosine, so 2 cosine squared of 3 theta minus cosine of 3 theta is equal to 0. What is the good option now? Factor what? Cosine of 3 theta, and I will be left with 2 cosine of 3 theta minus 1. I now have two equations I solve equal to 0. Cosine of 3 theta is equal to 0, and 2 cosine of 3 theta minus 1 is equal to 0. So, when is cosine equal to 0? That means when is the x value equal to 0 in the unit circle? When is the x value equal to 0? 90 and 270. So 3 theta is equal to 90 degrees and 270 degrees. I divide by 3 and I get theta is equal to 30 degrees and 90 degrees. The next one I solve, as I add the 1 and divide by 2, I have cosine of 3 theta is equal to 1/2. I inverse the cosine of 1/2 and I get 60. We had our little laugh about that yesterday, yes, no? Cosine is positive both in the first quadrant and the fourth quadrant. So now I have 3 theta is equal to 60 degrees and 300 degrees. Divide by 3 and we get 20 and 100. Let's see another type of challenging equation. This one is different from the others because of what? What makes it different? What makes it unique?
Two separate functions.
Yeah, we got 2 separate functions, right? We got a sine, we got a cosine. So what are we going to do? Why? Very good. Give Alex a round of applause, everybody. So speaks forth the intelligence. Thank you for enlightening us. He says that there's something that makes sine and cosine together, and that's tangent. Tangent is sine divided by cosine, agreed? So if we divide both sides by cosine, notice that he is able to get negative root of 3 is equal to tangent of x. Now it's an easy problem like we did yesterday. We draw our quadrants. Tangent is negative in the second and fourth quadrants. Inverse the root of 3 for tangent, and you again get what? Mom! I get the whimper laugh. All right, so then x is equal to
120.
300. I don't think so. I'm trying to follow exactly where you're thinking.
Like, there on these ones, we ignored that 3.
Yes,
until
and then
we
do that
got
later.
to the end.
Yes, if there's a number in front of the x, you deal with that at the end. Yep. Okay, cosecant and sine. What's the relationship between those two?
Reciprocal.
They're reciprocals. I'm going to write it as 1 over sine of x over 2 is equal to 2 sine of x over 2 over 1. And what could I do? Cross multiply. And we get 1 is equal to 2 sine squared of the quantity x over 2. What do you want to do now? Good. 1/2 is equal to sine squared of x over 2. A lot of 2's in this problem, isn't there? I'm not going to square both sides. We're going to... Let's talk about it. You got to get rid of this divided by 2, the squared, and the sign. Let's talk about what you do when and why. If you were to plug something in for x, order of operations would say you divide by 2, then you take the sign, then you square. So when we solve, we do the reverse order of operations. You first undo the square, then the sign, then the divided by 2. See that? Okay. So we will square root both sides. Square root of 1/2. Square root of 2 over 2. That sounds familiar, doesn't it? And because we're taking the square root of a variable, we list the positive and the negative. So root of 2 over 2. I have 4 solutions because we have the plus or minus. So I have first, second, third, and fourth quadrants. "45 degrees, very good. And so I get x over 2 is equal to, what are my 4 angles? Not quite. Multiplied by 2. 90, 270, 450, 630. Okay, sorry, just getting uncomfortable with this. All right. What is different about the next one? And don't say that it has sine and cosine, and that's what makes it different. Subtracting, zero product property. One's got a double angle, one has a single angle. Last time I paused for a while and the intelligence burst forth from this side of the classroom. Maybe it will come again somewhere. What do you think? What do we do? I'm gonna give a hint here. I'm gonna just say that sometimes I highlight certain. Oh, that didn't really highlight it, did it? What? Oh, speak forth, Rachel. The double angle thing. What do you speak of? That thing from last. Oh shoot! It was on our big formula sheet. Where's your big formula sheet?
It's in here.
I put another one at the end of your notes.
Oh. You know, I was
Yep.
You know what? Yeah.
So I'm going to get 3 pages of notes for the test. Notice this sheet of formulas right here, rather massive. And you get the others.
I was going to say, like, why do I see that again? I was gonna
Okay, so look at the double angle formulas piece. You see that the sine of a double angle is equal to 2 sine of x times cosine of x. Now I've gone from a double angle down to a single angle. That's the substitution. So we have 2 sine of x, cosine of x, minus cosine of x equals 0. Factor out a cosine. So I have cosine of x is equal to 0. And so yes, cosine is equal to 0 at 90 degrees. And then we have sine of x is equal to 1/2, where again is sine positive. We've done this about 10 times. First and second quadrants, it is 30 degrees. So 30 and 150. What up?
So how do we get to the 2 sine times cosine minus cosine? I'm just kidding. Oh, I see that now.
See it?
Yeah, I know. Thank you.
You're welcome. Which part? So I know that this, by our formulas, is equal to this. So I take that and I dump it in right there. So that goes in for that, and then I put it in for sine of 2x. So I replace all of sine of 2x with that. And I have a minus cosine. Better? Okay. 2 more problems. What about the next one?
Okay, I'm gonna even look. Okay, we're gonna substitute something. What do we have?
Sorry. I hated that.
What are we going to substitute?
Yeah, I'm trying to.
Nope.
Not bad. Okay, got it. Okay. Would it be something with cosine? We don't have any squares.
Yes, amen. Give it up for Caitlin. Woo! Caitlin says cosine squared is equal to?
Wait, where's the square?
1 minus sine squared. The only problem is I don't have a squared. Probably just square both sides. Yeah, like, why not, right? Like, that's the thing, isn't it? You know what I mean? Well, here's why, like, just square it, right? We can. But this is, to me, this is actually the most interesting part of this element. This is where you learn something that's super important. And that is this. When you have an equation and it's x to the first power, an equation with x to the first power, how many solutions are there? 1. That's the fundamental theorem of algebra. Remember that cool thing we learned? We see the power, that's the number of solutions. Now, this is different because this is not a polynomial, but still we could kind of apply some of these truths. And so if you have second power, you have how many solutions? 2. And if you have 3, you have so on and so forth. So the idea is that when the degree is increased, the number of solutions also increase. So if you're going to square both sides, great, that's a legal operation, but you're changing the possible number of solutions. So we can square both sides and use Caitlin's idea, but we're going to have to check our answers in the end to see if we created a solution that doesn't actually exist. Are you willing to do that?
Oh, yeah.
Let us commit to the long haul. Here we go. Let's square both sides. Cosine of x plus 1 squared. What is that? Where do you come up with this 2 cosine of x in the middle? Oh, you have to multiply the 2 binomials? Interesting. Equals sine squared of x. Now we're going to use Caitlin's great idea. It was 50% correct because she said that cosine squared is equal to 1 minus sine squared. I don't want to plug in 1 minus sine squared. I want cosines throughout the whole problem. Agreed? So I'm going to replace the sine squared with 1 minus cosine squared. Before I do that, where does this formula originate from? What is the number one? Sine squared plus cosine squared is 1. And from that, we can then come up with other formulas, but you have to know that one. Okay? You can't graduate from trigonometry and not know how to solve a right triangle and not know that sine squared plus cosine squared is 1. Got to know that. Super important. So I put that in there. I get cosine squared plus 2 cosine of x plus 1 is equal to 1 minus cosine squared. Yeah, add the cosines. So we got 2 cosine squared plus 2 cosine of x. Oh, if you subtract the 1, what happens? Oh, that's sweet. 0 product property. Factor out that 2 cosine. You guys are getting excited. It's like game day. Bring it on. Cosine of x plus 1. The 2 out front, we just divide that off anyway, right? And 0 divided by 2 is 0. So 2 just goes away. Great. So we have two equations. The first one is cosine of x is equal to 0. The second one is cosine of x is equal to -1. Where is cosine of x equal to 0? 90 degrees and 270 degrees. And where is cosine equal to -1? 180. I'm so proud of you guys that you know these values. But what did we say, Rach? You got to check them because we all of a sudden have three solutions. There might be one, there might be two, there might be three. We don't really know. We're going to check. We plug in 90. The cosine of 90 is? Cosine of 90 is? 0. Plus 1 equals, what's the sine of 90? 1. Is that statement true? Yeah, so we keep the 90 degrees. Now we try 270. Cosine of 270? 0. Plus 1. What's the sine of 270? Bleh. Does that work? Got to get rid of the 270. No bueno, compadre. Mis amigo. Plug in 180. Cosine of 180? -1 plus 1, and sine of 180 is 0. Is that true? Yep. Hey, Mom, guess what problem I didn't write in class today? I determined it is truthful.
I did mine.
No, it's okay. I was talking with other teachers at lunch today how it's tough because, like, when third quarter and fourth quarter come around, we're doing such challenging stuff. Sometimes we forget how to do the easier stuff. Yeah. Or you want there to be one. Is that why?
Well, I guess all the other ones are.
So just to be clear, when we talked about the fundamental theorem of algebra, it's a great question. The fundamental theorem of algebra and about that like degree and the number of solutions, it only applies to polynomials. So for example, x cubed minus x squared plus 3x minus 1 is equal to 0. That's going to have three solutions. But remember, there's three solutions, but some of them might be imaginary, right? And if they're imaginary, they also come in pairs. That's what we learned through the fundamental theorem of algebra. It applies to polynomials. So we can't state for sure the number of solutions that will occur, but we can state this, that if we increase the degree through squaring, we run the risk of adding solutions. We know that, okay? Yeah, we sure did. All right, last one. Ooh, doesn't this look like a doozy? What are we going to do?
Let's think this way.
Change? I like it. Make a chance. Say it out loud. Sine over cosine. Who knows if it works? Let's at least try it. What do you think? Valid option or not a valid option? Should we consider using this? Alex says yes. Why?
Because you can turn the cosine squared plus sine squared.
Oh my gosh, we get a sine squared there, don't we?
Yep.
And will we be able to achieve a cosine squared over here? Oh, we've actually seen this problem before, haven't we? Yep. Actually, 3 times, notes, homework, and study guide. So, let's go. We've got cosine of x over 1 plus sine squared of x over cosine of x is equal to 2. The only difference is there was never an equal sign on the other side. Now we have one. So Alex sees that this is a good option because it creates a sine squared, and he is now going to create that cosine squared. And thus, in the numerator, we get cosine squared of x plus sine squared of x, which Kenny says is, woo! Doesn't it just feel good to say that? Because you realize as you say that, like the rest of the population around the world will be like, why in the heck is that 1? And you're like, well, you must be enlightened in the class of trigonometry to know that. Yeah, we're enlightened. Darn right we are. You guys are smart. You guys are a bunch of geniuses. All right, so 1 over cosine is? Secant. So we got secant of x is equal to dos, which is Spanish for 2. Now what?
cosine of a half.
Cosine is a half. And when is cosine a half? Oh yeah. You know I'd end the problem that way. 60 and 300.
So just quick question. We don't
Yeah.
have to check it since we didn't square it.
Very good. Yep, you didn't change the degree.
Okay. Thank you.
Just to be clear, if you were doing a problem on the test and you come up with 60, if you start to make sounds like whoop, 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 or something like that, then I got to take a point off because you're obviously giving away an answer. Okay? All right? Fair enough?
Yeah, that's fine.
All right.
Because, well, what's one of the cosine?
All right.
So, sine, do you remember?
I'm going to let this conversation finish. I got to get you through your homework. Go ahead. You're doing, yep, finish it off. Then I got to help you with your homework quick. To go your homework. Yeah. I don't care if it's not done.
What do we change that to? That's what he just showed us that it's he just showed because we're left with one of the cosine. And the back cosine we have that as find
Okay. A horrible incident occurred when I was running off copies of your homework. And there was a massive paper jam. And in the midst of trying to clear the paper jam and rerun the copies, they ended up out of order. Are we strong enough to work through this challenge? On your very first page, so please with me, look at your first page. Okay? On the top of your first page, please write 1. Flip it over to your second page. On your second page, write 1. And on your third page, please write 1. That is all part of the first assignment. Okay? Flip it over, and the next thing you come to is this. This is actually assignment 3. Put a 3 at the top there. Flip it over. Now we get to assignment 2. Flip it over, and we get to assignment 2 again. Flip that over, and then you have the back side finally to assignment 3. And then it should be good after that. Again, I want to honor Miss Caitlin's choice to go to the senior dinner dance, and I do. As I said, it is in your best interest to make sure you get some equation solving stuff done this weekend. This is not a unit you want to fall behind in. Because just to be clear, if you don't do well on this test, the retests usually don't go very well. It's not like you all of a sudden just decide to start to figure it out. I'll be honest. So, all right, that's all I got for you.